Chapter 7.4 is an introduction to functions. It won't be a whole lot with this chapter, so this lesson won't take a whole lot of time. But what they do in the introduction to functions is, instead of writing the formula y equals 5x plus 7, which is number 10 on page 545, they say instead a function of x equals 5x plus 7. So you ask yourself, well, why do they do that? Later on they have functional values. This is math that will be beyond this course. But for now, we need to learn how to work with functions. So I'm going to erase this problem. And now what we're going to take a look at is problem number 6, which instead of y equals, now we say a function of x is equal to negative 2x cubed plus 5x squared minus x minus 1. And what they want you to do is solve if it's a function of negative 1, or if it's a function of 0, or if it's a function of 2. That's how this works. We're only going to do the very first one. We're not going to do the other two, even though in your assignment I would expect you to do all three. I'll show you how this works. Instead of writing a function of x now, we just write f of minus 1 equals negative 2 times negative 1 cubed plus 5 times negative 1 squared minus a negative 1 minus, that's a minus 1. So the function of negative 1 now is negative 2 times, and negative 1 times negative 1 times negative 1 turns out to be negative 1, plus 5 times negative 1 squared turns out to be a positive 1, minus a negative 1 minus 1. Then our function of minus 1 now turns out to be negative 2 times negative 1 gives me a positive 2, sorry about that. And 5 times 1 is 5. And positive, or negative times a negative 1 makes that a positive 1, and then minus 1. So our function of minus 1 turns out to be 2 plus 5, which is 7, plus 1 is 8, minus 1 turns out to be 7. And that's how that's done. Now what we want to do is we want to take a look at how do we graph a function. So we're going to drop down, and I'm going to erase this part. We're going to drop down on that same page to take a look at problem number 20. In 20, what we have is a function of x is equal to negative 3x plus 8. So when we set up our parameters, now we'll have the function of x, and we'll have x. In this particular case, what I'm going to do is put in a value for x and see what the function turns out to be. So I'll choose 1, 2, and 3. So if we take a function of 1, that's equal to negative 3 times 1 plus 8. Function of 1 then turns out to be negative 3 plus 8, and that function of 1 turns out to be 5. So we'll put a 5 in there. A function of 2 is equal to negative 3 times 2 plus 8. Function of 2 then turns out to be negative 6 plus 8. And that function of 2 then turns out to be 2. Function of 3, follow the same routine, negative 3 times 3 plus 8. F of 3 equals negative 9 plus 8. So that function of 3 turns out to be equal to negative 1. So for 2, we had, our result was 2. And when we use 3 for x, we get minus 1. Now we're ready to plot those points. So we go over to our graph. And in the first point, we have the function of x is 5. That's the same thing as saying y. And so it would be y is 5 when x happens to be 1. Now notice I've got them in reverse order there, and you might want to flip them, but make sure you got the coordinates correct. X is 1, y is 5. It sits right up here. In the second one, when x is 2, y is 2, and that one sits right about here. And then when x is 3, y is negative 1, that sits right down about here. And now if we wanted to plot those, we would just draw a straight line through those 3 points, and they should all line up. And now we have our answer. We've plotted the function of x, and we use f of x along the y-axis. You may want to reverse that and put the x first and f of x second. It might make it a little easier. So when you set it up, you may want to set it up this way. X, f of x. That way, when you're reading these points off, 1, 2, 3, and the coordinates 5, 2, and negative 1, you'll go to the x-axis first and that kind of thing. Something to think about. The third thing I want to talk about is a problem, and that problem is on page 546. We're going to take a look at problem number 24. It's a story problem. And they've come up with a formula. Not instead of f of x, what they say is p of x. That's a profit. And that formula for that, as they've figured it out, is $4.75 times x, where minus 9,000. And that x is equal to what they call units. All right. In this thing, it says an inventor in exercise 22, so you'd have to look at what 22 says, charges $8 per unit, and then his profit for producing and selling X units is given by the function. So it says, what is his profit if he sells 6,000 units? So what they do is P of 6,000 is equal to 4.75 times 6,000 minus 9,000. When I multiply that across, I'll get 42. 28,000.00 minus 9,000. I should put a comma in there. So the P of 6,000 equals that. So our P of 6,000, when we do the subtraction, what we come out with is a profit of $19,500. When they do this kind of thing, they start to figure out, okay, how many units do we need in order to have the kind of profit that we want? And then they set production goals. But the part that you're most interested in is in part C. And part C is, what is the break-even point for sales? The break-even point then turns out to be when the profit is 0. We haven't made any money, but we haven't lost any money. All right? So if this P of X now is 0, then what we get is the break-even point. We got the production formula, which is still 4.75x minus 9,000. We want to figure out how many units it takes so that our profit turns out to be 0. It's not P of 0, because that would be something different. This means we don't make any money, but we don't lose any money. So what we can do, of course, is add 9,000 to both sides. And we get 9,000 equals 4.75x. We divide both sides then by 4.75. And when we do that division, and that's, a little practice on the decimal division, what we get is 1,895 equals x. So there you go. Those are 3 sample problems. This should be a fairly easy unit for you.